Compute the limit as x and y approach 0 of xy divided by the square root of x squared plus y squared, or show the limit does not exist. Okay, so pretty simple two-dimensional limit expression here. I'm not sure exactly what my intuition is telling me here though, but I might just try a few cases to see if I can show the limit does not exist. And the way I'm going to do that is to think of some curves in two-dimensional space that approach 0, but different. Take different curves that approach 0 in different ways, and see if along those curves, see if the quantity approaches different values. So in particular, let x equal 0 and y equal t, so a parameter. Then I of course have, if I take a limit as t approaches 0 of, let's call it x of t, y of t divided by x squared of t plus y squared of t. This is equal to 0 because the numerator x, this quantity is always equal to 0. So along that curve, that's basically approaching the origin along the y-axis from above. But what happens if I take a different curve? Let's let x equal t and y equal t. Then I have the limit as t approaches 0 of, I'll just skip straight to what the expression is, t squared over t squared plus t squared under square root. So that's t squared over 2 t squared under a root sign, which is, oh, we're still getting 0 here, aren't we? 1 over root 2 times t squared over t. So that's equal to 0. What if I'm having another thought. Actually that I might be able to prove this fairly directly. I'm going to try one more attempt here. Let's let x equal t and y equal t squared. Then we have a limit as t goes to 0, t cubed divided by t squared plus t to the 4 under square root. So that's t squared. We factor t squared out of the bottom. So this is t squared, t cubed divided by t times the square root of 1 plus t squared. That still goes to 0. I'm thinking of using is there something I can say about the product of two numbers and the sum of their squares, right? I've got x squared plus y squared compared to x squared times y squared. Right? I mean, I know that one of these has a square root, but I'm just squaring the other one instead. I'm starting to think that the answer is going to be 0 because, you know, x times y, if we think of x and y as having units of, let's just say, distance, that has units of distance squared, whereas x squared plus y squared has units of distance. So the thing up here is in some sense smaller than the thing down here. But how do I make that comparable? Okay, I think I can do it this way. Let's let epsilon be positive and let delta be equal to the minimum of 1 and wait a minute. Oh, I had it at this point. Okay. The quantity I'm concerned with is xy divided by x squared plus y squared in absolute values. Okay, so this is equal to the absolute value of xy divided by root x squared plus y squared. This is less than or equal to, I replace the numerator with the maximum of x squared and y squared. Then I get this. And the maximum of x squared and y squared is less than x squared plus y squared. And this is equal to root of x squared plus y squared. So if x squared plus y squared under a root is less than delta with delta equal epsilon, then this quantity that I'm concerned with I've shown is less than epsilon. So this implies that the limit as x and y goes to 0 of this quantity, xy divided by x squared plus y squared, this is equal to 0. Okay, I should have clued in earlier that because the numerator is in some sense a higher order than the denominator, that as everything gets smaller, this should go to 0 faster than the denominator. This is quadratic, but this is basically linear. Yeah, so the numerator kind of dominates in terms of how small things go, and this goes to 0. Yeah, that wasn't bad. I also got a little bit hung up sort of running in circles in my mind with what I was doing here, but this seems to be a fine way to go about it. All these inequalities, this one should be obvious, right? If I replace x and y with the maximum of x and y, and then I'm multiplying them together, then clearly this product is less than the maximum of either of these two things. And the maximum of two things that are both positive will be less than the sum of those two things. And then we have a nice cancellation. And given an epsilon, you can choose delta to be equal to epsilon, and it all works. Yeah, I don't have much more to say about this one. Thanks for watching.